Hello, my name is Dennis Hancock. I get to be the Center Director for the U.S. Dairy Forage Research Center up in Madison, Wisconsin. And I was asked to talk today about practical considerations for making high quality baleage. Let's start with just a brief review about silage. Silage is nothing more really than the pickling process of taking forage and fermenting the sugars that are inside of it into an acid. And those organic acids actually inhibit the growth of fungi. Now this must occur in anaerobic conditions. There cannot be any oxygen getting in here, or else that allows the fungi to get an unfair advantage. So if it is an anaerobic situation, we get this pH drop, and a low pH actually reduces the enzymatic activity of some of the undesirable species, including some of the bacterial species like the Clostridial bacteria that actually end up causing botulism, which we'll talk about later on. Now, silage has been in use since 1500 BC. There's evidence from sources about Egypt and Carthage that it was actively being done 1500 years before the Common Era. So why choose baleage over hay? Well, one of the main reasons for that, of course, is weather-related issues. If we think about the common factor there of the weatherman getting the forecast wrong whenever we fire up the hay mower, we constantly are running into situations where rain damage is a real threat. So let's look at this a little bit more in detail, and I'm going to pick some data from my master's research, actually, from back in the late 1990s. And this was a study that ended up getting published in 2006, where we looked at, in this case, the fiber components, the NDF, the neutral detergent fiber, and here we want that number to be low. Okay, we want a lower number here. Lower number of NDF is higher quality. So if we look at pre-storage, before we actually ever stored it, you can see that those values for hay and silage are fairly similar, but notice that this storage loss that occurred here in trial 1. Now, if we look at trial 2 in a very similar situation, except for we got rain damage on our hay. And then we also had some storage loss that was associated with hay being stored too. So what is really happening here with baleage is it's helping to reduce the risk of rain and storage losses. So in addition to this, silage has many benefits. Beyond just the rain damage aspect and the storage loss aspect, it enables us to be more timely in our harvest. So we can fit in a 1 or 2 day window for harvesting our forages a lot easier than we can a 4 or 5 day drying window that sometimes never develops. So it also allows for less shatter loss. So if it's harvested wet, we don't lose as many leaves. And that's where the quality really is. So we end up with much higher quality, lower fiber levels, higher protein levels, increased digestibility, and increased palatability. The cattle and the animals that are consuming it generally like it a lot better. But silage does have a few risks. One of those is the expense of the equipment, the labor, and plastic. And that's usually pretty expensive for most operators. So it's really unlikely to be economical for smaller herds. The other thing about the plastic is that recycling is not really practical nor economical. So that is one area of loss, and that's a real challenge in the system. The other thing to remember is if we put garbage into that plastic container, we're going to get garbage right back out. There is nothing magical about silage. It's not going to take good stuff and turn it in, or bad stuff and turn it into good. But it can take good stuff and turn it into bad if we're not really careful about what we're doing. One major aspect of this is moisture management, and moisture targets are still pretty challenging to hit consistently. And we'll talk a little bit about that later on. If we go too wet, then we really run the risk of secondary fermentation and botulism poisoning. Conversely, if we go too dry, we don't get the fermentation that we really want, and that product is not nearly as stable. It may be a lot more moldy. So here is an exaggerated version of baleage bale here, and inside of that baleage, inside of that forage are sugars. So what's happening in this situation is these lactic acid forming bacteria, these are LAB, or lactic acid forming bacteria, are acting on those sugars, and in the absence of oxygen, here along this side here, we have all of this is being excluded, all of this oxygen is being excluded from the system. We have a plastic layer here in the case of baleage that's keeping that oxygen out of the system. So in the absence of that oxygen, those sugars are converted over into lactic acid. Lactic acid forming bacteria, no surprise, they form lactic acid. And that's the principal component of what we're looking at here. And that's really what we want. We want more and more lactic acid as much as we can get. Now, there are some heterofermentative bacteria, not the LAB, but some heterofermentative bacteria that can form some lactic acid, but they also form things like acetic acid, things that kind of give it a vinegary smell. And then other side products here too, propionic acid, carbon dioxide, which is a major source of dry matter loss. Sometimes we can get a little ethanol production there. And then here is one of our biggest concerns is butyric acid. And I'll talk more about that, but we want those butyric acids to be as low as possible and the lactic acid levels to be as high as possible. So with that pH, with that acid forming, we get a pH drop that comes along. So within just a few days, we start seeing a pH drop, and those heterofermentative bacteria start kind of falling by the wayside as the lactic acid forming bacteria end up taking over. And eventually that pH can be driven down into the low 4s. In some cases, like in corn silage, we may be down in the 3s in terms of pH. Now this is more typical for a grass curve. If we look at legumes, generally speaking, they are more buffered against a pH change, meaning they don't change as readily or as easily. So they may never really get below about 4.7. But in any case, we want to make sure we're getting below 5. That's really our target. We want that to be our pH at least below 5. Now, when we talk about baleage and compare that, for example, against chopped silage. So here in Madison at our research dairy, we make chopped alfalfa silage, and we put those in bunkers or in ag bags or something like that. And generally that pH drop is really, really rapid. However, with baleage, we don't get that rapid pH drop, nor does it go nearly as far down. So it's not uncommon at all for us to be in the low 5s rather than below 5. We really want to be down below 5 though. That's the goal. And again, if we look at the comparison between baleage in the yellow here and chopped silage in the green, you can see that early on there's a difference, and throughout, at the end of this fermentation, the chopped silage is a lot more thoroughly fermented, not only in terms of lactic acid, but also in terms of total fermentation acids. So you're getting a more thorough fermentation in chopped silage than you are in baleage. Now, that still can be a sufficient amount of acid for it to be really good and stable. So that does not mean that baleage, is not a good silage. It can still be really good feed. It's just that it's not as thorough a fermentation, and therefore it can be a little bit riskier. So baleage is easier to deal with, uses a lot of the same equipment as we use in haymaking. It's more portable to a degree even. And for most cases, it's going to be more cost effective for those medium scale producers. Fermentation is not necessarily as rapid nor as complete, and so that pH drop never really reaches the ideal levels that we would see in chopped silage. In chopped silage, it can go into the bunk a lot faster, especially if we're using scale appropriate equipment, but it does use that specialized equipment that can be a lot more expensive, and it needs to be stored near the feeding area, wherever we're going to be using it. Now, if we think about the cost effectiveness of something like this, it's really only going to be appropriate for the larger scale producers. Fermentation is going to be a lot more rapid and more thorough, and that pH drop is going to be much more ideal. But if we're going to make baleage, we really need to pay attention to the details. The details. Now, you don't have to be really good at spelling, but you really have to pay attention to the details. So the first detail is no rain damage. We don't want to be putting up baleage that has been rained on. It does the same thing to baleage as it does to grass hay or hay that we're trying to dry down, is it's going to leach out some of the soluble carbohydrates, and therefore it's going to reduce the sugars that are available for fermentation. The other thing we need to do is to plan ahead. We need to be able to wrap and bale, or bale and wrap in that order, within 12 hours. So we need to make sure we don't cut down any more than we can the next day or whenever we get ready to bale it all and wrap it all within 12 hours. We need to maximize the bale size, but we need to account for the fact that those bales of the same size are going to be about twice as heavy as an equivalent sized hay bale. We also need to be making really good dense bales. The denser it is, the better the fermentation will be. We also want to use a baler with a pre-cut system if possible. That way, if we are using it in a mixed ration, it's a lot easier to process that way. If you're just feeding a bale at a time, there's nothing wrong with that at all. In that case, a pre-cutter may not necessarily be all that advantageous. Now, I also advocate the use of net wraps. Net wrap actually can speed up field efficiency, but it also helps to lay down the stem so you don't get as many holes poking through the plastic as you're getting ready to wrap it. The next detail is to choose a site that's really appropriate for wrapping. In many cases, it needs to be near the feeding area. That's really the ideal so that you don't have to handle it or risk damage to it. You want to ensure that the site that you select poses a low risk of damage. What do I mean by that? Well, I want a site that has a good sod to it, doesn't have a lot of weeds around it that are going to potentially poke a hole through the plastic or provide a habitat for rodents or something like that that other animals may be chasing around. Coyotes are really bad about chasing those rodents, and they might jump on top of the plastic bales and start rolling around on it. And that's a very common problem is coyotes or dogs or other things that are chasing things through the storage area can do some damage there. It's also important, I think, to locate it at least about 12 feet from a fence line. This is important so that one can minimize the bird traffic. So birds have a tendency to light on top of the bales, and they want to pick at the bales. Sometimes they'll try to see something underneath there that they'll want to pick at, and that can introduce holes. The other thing you want to do is regularly observe those areas to see if there's any damage that wildlife or vandals have caused. And if there is any damage, to go ahead and tape those holes using a UV treated tape. Greenhouse tape or baleage tape is absolutely crucial there. So apply the plastic appropriately as well. That's another detail. 6+ layers on individual bales is really ideal. 8+ layers on inline bales is ideal. And it's also important to use end caps and to tape any holes. Now, I know there are a lot of producers that will just leave that end bale open and they won't wrap it. That bale is going to deteriorate. It's not going to be worth feeding, or if you do feed it, it could cause some injury or death. So it's highly advised to use an end cap. That $20 or whatever it costs to use an end cap is money well spent in most cases. Now, ensure that the wrap is being routed through the stretch rollers appropriately. Make sure that that tacky side is toward the bale. And you also want to clean those stretch rollers regularly as well. That is most commonly the reason why we have poor plastic coverage, is that those stretch rollers get gummed up with all that tacky stuff off the wrap, and they don't roll as easily, and they are overstretching the plastic. So make sure that it's in an acceptable range of 50 to 70% stretch, and you can use a little ruler and make 2 marks an inch apart, and then run it through the stretcher. And if it's 1 3/4 inches or more, then you're definitely overstretching that plastic. So the next thing you want to do, and this is the most important part of this whole thing, is to make sure that our moisture levels are at 40 to 60%. This is really crucial. Again, referring back to some of my early work with alfalfa baleage here, if we are in that 40 to 60% range, notice here as we get closer to 60, our pH drop is quite good. We're down into the 4s here. Now notice here though, with low moisture, 40% moisture or below, in this case it was 37% moisture, we were above our pH 5. Our target really needs to be 5 or below. Now, moisture targets are often missed. Here's some work that was done in Kentucky. Jimmy Henning did some survey work with some county extension agents there. Some great information came from that, and what they found is that there's more samples that fall outside of that moisture target than fall inside of it. If you count up what's in the 40 to 60 range here, there's only about 27 that actually fall in there out of the 57 that were in this survey. So it's really, really important to pay attention to that detail. That's a crucial step. Now, how do you determine moisture? That's not as easy as it sounds. There are some challenges in determining moisture, and one of those often used tools is a hay moisture probe. And those moisture probes will get you in the ballpark. Oftentimes, in some cases, they may not even be accurate enough for the high moisture levels, but those that really are designed for high moisture levels, they'll get you close, but they're really not extremely dependable. You really still need to calibrate your field. I would say in many cases, producers that have experience with this, once they're calibrated, they can be as accurate or maybe even more accurate. And this dish rag test, I think, is a really great tool too. So if you wring out a handful of forage and you can express water, if there are little droplets of water that come out of that dish rag as you wring out that forage, well, it's too wet in that case, and so you need to let it dry a little further. The microwave moisture test is a pretty common strategy, and that works if you've got a power source and a microwave near the location. Do not use your wife's microwave. Ask me how I know. That's an important consideration. You also need to consider using a drying oven or some device, like a coaster device, for example. That's basically a hair dryer on steroids, and one can use it to dry down the hay, and a scale dry down the forage, and a scale here you can use to measure. Once it gets down to stable weight, you can assess how much moisture was in it. Now, there are some built-in systems or add-ons that go into balers, and those systems can be quite accurate, although I've got a question mark here because there's not a lot of data on this, just some experiences that folks have reported to me that by the volume of material going through there, they've been able to pretty consistently get good numbers on moisture. Now, let's look at the effect of moisture content on lactic acid levels. As that moisture level increases, in general, we're going to see our lactic acid levels increase as well. Now, here is the recommended range, 40 to 60%. So if we're in that range, we're going to have some decent level of lactic acid here. Now, even all of these numbers from Dr. Koblentz's work here at our Dairy Forage Research Center up in Marshfield, you know, really those levels are still quite low. That's not nearly what we would see for silage in a bunk. Here's some survey data that, again, from county agents in Kentucky, kind of summarized by Jimmy Henning. And some great work here where they looked at the green dots here represent lactic acid levels. And yeah, as we get in that above 60% moisture, we're going to actually increase our lactic acid levels. However, we'll see in a moment that's not necessarily an ideal situation. Let's come back to that but for right now, notice that if if we're in that 40 to 60% range, we're getting a fair amount of lactic acid formation. pH is dropping down at least near 5. And so there are some real important numbers here to see that if we're in that 40 to 60% range, we're doing well. Now let's take just a side note here and talk about botulism for a moment. The fear of botulism, I think, is a major barrier against producers adopting the use of baleage, and this is a risk that really can be kept under control if we keep our moisture on target. And that's really the key. If the pH in the silage fails to drop low enough, a secondary fermentation can occur. And a secondary fermentation is when there's enough moisture to support fermentation, but the pH is still pretty high, and whatever sugar and lactate may be available can be used by other anaerobic bacteria for energy. And one of the things that comes as a side effect of that is butyric acid and carbon dioxide loss. That's dry matter loss, basically, is what's happening. So you're losing valuable forage there. Now, a common soil bacteria, Clostridium botulinum, is one of those that can contribute to that secondary fermentation. Now, Clostridium botulinum also produces the botulinum toxin, one of the world's most potent neurotoxins. And this is an extremely dangerous situation if we end up with a botulism case. So let's look at butyric acid, because it's usually our best indicator of botulism, or at least the risk of botulism. So here we have moisture on the x-axis and butyric acid on the y-axis, and we want these numbers to be as low as possible here. We want low butyric acid numbers. If we're in that recommended range, the higher we go here, the greater the risk of botulism that we're going to see, all right? So let's look at some actual data from a compilation of studies that Dr. Koblenz did here at the Dairy Forage Research Center. And what you can see is as we get above that range, then our risk of having higher levels of butyric acid are quite significant. And so what we really want to do is stay within that range, try to keep our risk as low. The proportion of these samples that ended up having some level of butyric acid are much lower as we go lower in moisture. Here's some survey work, again, from Dr. Henning and the county agents there at UK Extension. Some really good information here looking at butyric acid levels. And notice the scale is a little different than the previous graph, but notice here, again, as we go higher, the more dangerous the situation is. So if we're in that 40 to 60% range, our risk is much lower than if we are out about 70% or so. The other thing we want to do is to make sure we avoid the risk of contaminating that forage with soil. We want to adjust our harvest equipment to minimize soil contamination, and that's especially important with the cutting height and the angle of the disc mower. We also want to be less aggressive with the rake and adjusting that rake so that it is just touching above the surface and not actually scratching the soil as much. We want to use a rotary rake or a merger rather than a wheel or parallel bar rake. We want to also test our baleage for quality, including measures of our fermentation. So we want to take that sample about 1 month after wrapping so that it has plenty of time to ferment, or up to about 30 days before feeding. Now, I prefer doing it a little closer to feeding, so right at about 30 to 60 days is my preference, so that we have time to make any changes in the feeding program appropriately. Now, again, anytime you're taking forage samples, you want to take a good number of cores and about a minimum of 20 cores per sample to really represent that forage lot. Be sure to tape up the holes with a good baleage tape again, excluding as much oxygen as possible. And here, as we look at the fermentation quality ideals, this is what we're shooting for. We want a pH below 5. We want lactic acid as high as possible, but at least above 3%. Butyric acid as low as possible, possibly lower than 0.1% would be ideal, but the lower the better. Ash content, which is a measure of how much soil contamination we got. We want that to be less than 10%. So in summary, baleage has many advantages, and it can be very cost effective, especially for medium and large scale producers. Success with baleage requires paying attention to the details though. And baleage is not without risks, but good management keeps those risks low, especially good moisture management. Always, always, always test your baleage quality, even if every detail went just as planned. We want to make sure that we're doing a good job of ensuring that the quality of feed that we're providing our animals is sufficient to their needs and won't cause any kind of negative effects. So with that, I'm happy to address any questions that you might have. Here's my contact information if you'd like to contact me after the fact. Thank you very much.